In this session we will be solving rational equations. As with any equation, when we need to solve it, we're going to be finding a specific value or specific values for the variable involved. Now the way that we solve rational equations is to first determine what the lowest common denominator is. Then multiply both sides, multiply everything by the lowest common denominator, and then solve the resulting equation. And we also must check for what are called extraneous answers. Those are answers that we get after we solve the problem, but when we plug them back in, we end up dividing by 0. Remember, we can never divide by 0. So if we start off with 1 divided by 4 plus 9 over x equals 1. First of all, we need to find the lowest common denominator. Anytime we have a whole number, like 1, it always has a common denominator of 1. So here, the lowest common denominator is going to be a 4x. So if we multiply both sides, everything by 4x now, we'll have 1 times 4x. So we'll have 4x over 4. That takes care of this part. And we'll have a 9 times 4x. So we'll have plus, and we'll just say 4x times 9. I'm not going to multiply it out yet, and you'll see why. And then this side now, with that 1 times 4x, so that's just a 4x over our 1. Now, looking at this problem, we're going to see what can cancel. And if we have found the correct lowest common denominator, things should cancel everywhere such that we are left with no more denominators. So starting at the very left, this 4 will cancel with this 4, this x with this x. In this case, I actually could have multiplied the 4x and the 9 together to make 36x. But in the future, sometimes, if you multiply everything by the lowest common denominator and leave it separate, like I did with the 4x times 9, it can make it more simple. And then finally this 4x over 1 here, since it's a common denominator of 1, we can just say there is no denominator. So now what are we left with from this? Well, we're left with x plus 36 equal to 4x. Now all we have to do is solve for x. So I'll subtract x from both sides. I'll have 36 equals 4x, 3x. And then I'll divide both sides by 3. So now I get 12 equals x. So that's the solution I got. We're not quite done, because we need to make sure that this solution is not an extraneous solution. So if we go back to the original problem here, I'll write it out again. 1 over 4 plus 9 over x equals 1. If we say that x is equal to 12, are we going to end up dividing by 0 once we plug that number into everywhere that we see x? So that would mean a 12 there. No, we're not going to be dividing by 0 at all. So x equal to 12 is a valid solution. Now let's take a look at another problem. Now let's say we have 6 over x plus 3 plus 48 over x squared minus 2x minus 15 minus 7 over x minus 5, all equal to 0. So just like with rational expressions, one of the first things that we're going to need to do in order to determine a lowest common denominator is to factor each individual numerator and denominator. So here we only need to do that one place, and that's the place of x squared minus 2x minus 15. This will factor to x minus 5 times x plus 3. So now we're going to rewrite the entire problem with everything factored. So we'll have 6 over x plus 3 plus 48 over x minus 5 times x plus 3 minus 7 over x minus 5, all equal to 0. So now it's much easier to see what the lowest common denominator would be. Here we have x plus 3 and x minus 5. This one has both. So we know that this side is missing an x minus 5, and this side is missing an x plus 3. The lowest common denominator is going to be both. the x minus 5 times the x plus 3. So now we're going to multiply everything by that lowest common denominator. So when we multiply everything by the lowest common denominator, now we'll have our 6 times the lowest common denominator plus where 48 was, now that times by the lowest common denominator. And then finally multiply the 7 that we had in our problem by the lowest common denominator, because we have to multiply everything by it. And then it's still equal to 0, because of course 0 times that lowest common denominator will still leave us with a 0. If there was a number out there, such as a 3, a 4, whatever, we'd also multiply that by the lowest common denominator. So now, just like in the previous problem, we're going to see what can cancel. And we know we've done it right if all of the denominators are now gone. So starting at the left, this x plus 3 will cancel with that x plus 3. And x minus 5, and x minus 5, and x plus 3, and x plus 3. And x minus 5, and an x minus 5. What are we left with now? 6 times x minus 5 over here, plus just a 48 here, minus 7 times x plus 3 over here, all equal to 0. Now we just need to solve the resulting equation. So we'll have 6x minus 30 plus 48 minus 7x minus 21. Remember, when you're distributing the 7, it's the negative 7 too. You don't want to forget that. That negative distributes to each as well, all equal to 0. Now if we add like terms, we have 6x and a negative x, negative 7x, so we'll be left with a negative x. Then negative 30 plus 48 will give us a positive 18, minus 21 will now give us a negative 3 equals 0. Add 3 to both sides. We have negative x equals positive 3. We're not solving for negative x, we're solving for positive x. So we'll divide both sides by negative 1, so the negatives cancel on the left. So finally we get x equals negative 3. Now remember, we always need to check for our extraneous answers. So if we go back to the original problem, right here, everywhere that we see an x, we need to now plug in a negative 3 and make sure that we're not dividing by 0 anywhere. Well, I can see right away in this denominator, we plug in a negative 3 for x, we're going to get negative 3 plus 3, which is clearly a 0. Cannot have that 0 in the denominator. So all that hard work to find this x equals negative 3 actually led us to an extraneous solution. So it is a solution, but it's not a valid one. On the AccuPlacer, that would be an option. It would say either no solution, or it would say x equals negative 3, however extraneous.